Hi guys, we're looking at the cosine rule today. If you're on text and test 4 there, it's page 115. This is the same triangle that we saw for the sine rule. Okay, so you've got this angle A, then the opposite side has to be A, lowercase. This angle is B, uppercase, opposite side is lowercase. This angle is C, opposite side is lowercase c. Okay, here's what the rule says. It's in the log tables. I'll explain it now in a second. We're not going to derive it here. We'll derive it again at another point. It says c squared is equal to a squared plus b squared minus twice ab times the cosine of c, that angle opposite. Okay, before we go any further, there's two more versions of this. One that starts with a squared equals and one that starts with b squared equals. So maybe just pause the video there and see if you can write out those two yourself based on the same pattern, okay? So c squared, you'll notice, is opposite this angle c, and that's the only place that appears. Give it a go. Okay. Hopefully, you've stopped and given it a go, and you've said a squared is b squared plus c squared minus twice bc cos a. Okay, b squared plus c squared minus twice bc cos of this angle in between them, b and c. And b squared is a squared plus c squared minus twice ac cos b, the angle in between them. So a squared plus c squared minus twice ac cos capital B. Okay, so what might a question look like? Well, you might be given a triangle here where you're given two sides, an angle, and you're asked to find that third side. So what does the cosine rule say? Well, it says x squared is the same as 5 squared plus 8 squared minus twice 5 times 8 cos of 62. Okay, so working the calculator work on that, you should get x squared is 51.44. So x then is the square root of 51.44. And the square root of 51.44 is 7.17. Same unit as the question. So if that was centimeters, then your answer is centimeters as well. Okay, so that's that distance there, 7.17, according to the cosine rule. Another type of question might give you three sides and leave an angle unknown. So here you'd say, pick the side opposite the angle. So start with 12 squared, okay, because those are the two things you're working with, C and the angle opposite C. You want to make sure the angle that the formula refers to is the one opposite this side, c squared. Okay, so 12 squared is the same as 7 squared plus 8 squared minus twice 7 times 8 cos of a. Okay, so there's the calculator work done on that there. Bring that over. 144 minus 113 makes 31, is minus 112. Cos A, divide through 31 over minus 112 is cos A. Okay, so that means you've got a negative cosine. We haven't really seen how to deal with that property yet, but still, A is the inverse cosine of 31 over 112. Excuse me, negative 31 over 112. Okay, and most of your calculators will produce an angle of 106.07 there degrees if you put that in. You may also get an answer of negative 74 degrees or 73.95. And if that happens, you take the answer away from 180. Okay, and we'll be doing a class on how all of this bigger than 90-degree angle stuff works at a later point. For the moment, just trust your calculator for these ones. All right, next question. This one here is question 8. We're going to come back to 7 in a second. The lengths of the sides of a triangle are 4, 5, and 6. The largest angle in the triangle is theta. Find the value of cos theta as a fraction. So our lengths are 4, 5, and 6. The largest angle is always opposite the largest side. So there's 6. Doesn't really matter where you put 4 and 5 for the moment. The question is find cos theta. Well, you're going to use 6 squared because that's opposite the angle is equal to 4 squared plus 5 squared minus twice 4 times 5 cos of theta. Okay, and there's the calculator work, 16, 25, 40 cos theta. That 41 there, you bring it over, you're going to get minus 5 is minus 40 cos theta, and dividing through there, cos theta is minus 5 over minus 40, which is plus 1 over 8. Okay, so theta is the inverse cosine of 1 over 8, although I think they just asked for cos theta, so let's leave it there and have a look at part 2. So yeah, cos theta was what they asked for. Hence show that sine theta can be written as a root 7 over b, where a and b are integers, which means whole numbers, and write down their values. Okay, let's do that. Okay, well, if we know that cos theta is 1 over 8, we can draw what's called a model triangle, where we say our adjacent side is 1 and our hypotenuse is 8. Okay, which means cos of theta is 1 over 8. Once you have that, Pythagoras tells you that this side here is going to be 8 squared minus 1 squared, or root 65. Excuse me, root 63. And then you say, I'm going to say this just because it tidies up a little bit. It's going to be a little bit more obvious where things are coming from. That root 63 has a square factor of 9 times 7, and 9 is the square factor. So that's 3 root 7. So you can see that root 7 already appearing. Okay, and that's our opposite side. There's our hypotenuse. The question was, what's sine theta? Well, it's going to be 3 root 7 over 8. So our two integers, a and b, are 3 and 8. That's the second part of that question. And finally, question 7 there says, in a triangle ABC, AC is 15, AB is 12, and the area of the triangle ABC is 65 centimeters squared. So the first thing you do here is go and draw yourself a diagram. So here's our triangle, ABC. We've been told that AC is 15, AB is 12, and that the area, so let's just say area, is 65 centimeters squared. Find the angle BAC. This is what they're asking for, this angle here. Okay, and I'm actually just going to call it capital A, just to simplify it. So what links area with two sides at an angle? Well, that's our area formula from the last section, which was the area is a half AB sine C. Okay, or in our case, if that's A, it's going to be a half BC sine A. Okay, so that's 65 equals a half of these two sides, 12 times 15 times the sine of the angle in between them, which we've called A. Okay, well, that's a half of 12 is 6 multiplied by 15, 60 is 90 sine A, and dividing through 65 over 90 is sine A. You can simplify that if you want to, but all you have to really say is that A is the inverse sine of 65 over 90. Okay, and that's a bit of calculator work. There it is there, 46.238. Corrected 1 decimal place, I think it said, so 0.2 degrees. Excuse me, it said find BAC to the nearest degree, so it's just 46 degrees. Find BC in centimeters, correct to 1 decimal place. Okay, that's this distance up here, which I'm just going to call X so that we can use that in the equations. We now know that this angle A is 46 degrees. So the second part of this is use the cosine rule. I'm running out of space, so maybe I'll work down this section here for part 2. A little bit messy. But the cosine rule says X is opposite 46. So X goes on one side of the equation, 46, it's cos 46 that you're going to have on the other side. So X squared is 12 squared plus 15 squared minus twice, oh, I'm really running out of space here, 12 by 15. Okay, really sorry about that. Let's tidy that up. X squared is 144 plus 225. Twice 12 is 24. Twice 15 is 30 times 12 is 360. Costs 46. Okay, so here's the calculator work on that. X squared is 369 minus, that comes out as 250.07. Take that away, you're left with 118.9. So that's x squared. Take the square root to get x is the square root of 118.9, which is 10.9 centimeters. Okay, so that's all I'm going to put in this video. I might ask you now to go to page 115, try questions 1 and 2 yourselves, and I'll see you in class tomorrow.